So what I'm going to do is I'm going to do a few more sample questions for you. I provided you with the actual question there. Yeah. So example number one, the demon drop is a... Pardon me? As I was saying, the demon drop is a ride at an amusement park. You watch it and you time its ride, or time its free fall to be a time of 1.5 seconds. Now, I hate to admit this, but this is stuff that I do.
What?
I go to like...
amusement park, you don't even ride the ride.
I can't anymore. But I have been to Canada's Wonderland just north of Toronto, and there was one ride that I had to think about. I wonder how high that is. And then I got standing there thinking, okay, I can figure this out. So I mentally calculated all these things, and then I approximated this and that. And then when I got home, I looked it up, and sure enough, I was within about 3 meters of it. Yeah. No, it was awesome! It was an awesome ride, but it was a ride that there's no way that I'm going on. Right? They had this, I'll explain it to you. It was like a giant swing, okay? So there were these two great big poles, kind of like this, right? And a wire like that, and they put you in here, right? And they strap you in, right? So you're actually flying, right? And then they sort of, and I can't do it, but like they pull you back up on another wire like this kind of thing, right? And then they give you a little release, and then you pull it, and then you go flying down. So it's like a big swing, right? And we were standing just on the up part. They were swinging right towards us. I remember standing right underneath this girl went right over top of us like this, and she's just screaming the whole way, right? And I'm watching, and I was wondering how fast she was going to the bottom. Then I realized, you know what? This is not a good spot to stand. Directly underneath the path. This is a terrible spot. So we'll move to the side, yeah. But so I calculated. I wanted to know how high it was, and so I figured it out.
Yeah.
I know. My life, A physics. Yes. All right. This one's a little easier. You time its free fall at 1.5 seconds. How fast is it going when it reaches the bottom? So it's one of those ones where they drag you up to the top, right? And then they let go and it just screams down and at the last second it stops. How fast is it going when it reaches the bottom? Just before it crashes into the ground. How am I going to figure this out? Well, let's do a little bit of...
Do we even have any of the things?
The initial velocity is 0 because it's dropping. The acceleration is?
Half that.
On Earth, minus 9.8. And we know the time is 1.5 seconds. And my question is, how fast is it going? So I'm solving for VF.
Are we supposed to write this down? No. It's got it on the report. Okay.
I would write it down. It's on the sheet. You should probably write the solution down. Okay? Going through solutions, writing down solutions definitely will help you. Okay, how am I going to do this here? What's one thing I can do? With an A and a T, what can I do? A equals delta V over delta T. Do I need to worry about minus 9.8?
Yeah.
Yeah, we probably should.
So why wouldn't you worry about it?
There are times, I'll show you here. When we get to the bottom, I'll show you the difference. I think you'll see it. So A is minus 9.8. The delta V is what we don't know. And my time is 1.5 seconds. Which gives me a VF of, a delta V of minus 14.7. My velocity changes by minus 14.7 meters per second. Is the initial velocity 0, Joey?
Yes. So you said it.
Which one? Yes, of course it is. It's dropping, right? It's 0.
14.
Therefore, this tells me then that the final velocity is minus 14.7. Why is it minus? Because it's going down. If I didn't worry about the minus 9.8, what would happen here? This would just be a positive, and would it be the end of the world? No, you would just have to recognize that that's the speed, and it would still be down, right?
You could just say it was going 14.7 down.
Sure, you could. There are situations, and I'll show them to you very soon, where the minus 9.8 really does matter. And I think you should recognize the difference between the two when I get there. So how fast is it going when it reaches the bottom? Minus 14.7. How high is the ride? Can you tell how high the ride is? Remembering that V bar is d over t. The only thing that's got d in it has the average velocity in it. I have to find my average first, exactly. V bar equals Vi plus Vf all over 2. V bar is going to be equal to 0 plus a minus 14.7 all over 2, giving me negative 7.35. Now I go V bar equals d over t minus 7.35 d over my time. Yep. How come I get negative?
Because it's going
How come I get d of a minus 11.025?
It's going downwards.
Yeah, it's actually a displacement. It's going down. Exactly. If the question says how tall is it, it's 11 meters tall, right? Would I accept minus 11? Absolutely. It's a displacement. How hard is that question? Relatively easy. Yes, relatively easy compared to some of them. Shall I skip the hard one for now?
Yes. Yes. You worked hard today. I'm trying to comprehend your.
Yeah, my craziness?
Yeah.
I might need to warm you up, though.
Oh.
After that one.
You know what? Let's do example number 4 first. There's a reason for this. I'm going to rearrange these order next time for the next group of kids. This time, instead of something falling, free fall, it's thrown upward with an initial velocity of 22.5. So I take my tennis ball and I throw it upward at plus 22.5. It's caught at the same distance above the ground from which it was thrown. In other words, when I throw it, I catch it at the same height. I don't worry that it's going to drop another meter or so. That's all I'm saying. How high does the ball rise? How far up does it go if I throw it up at 22.5? And how long does the ball remain in the air? Do I need to worry about positive and negatives here? I've sort of implied it with this here, haven't I? Why does it matter here? The velocity is up, the acceleration is down. Are we talking about two different directions here? Up and down? Yeah, we are. In the demon drop one, were we talking about two different directions? No, it was just one, right? So when there's only really one direction involved, the negative sign really doesn't matter because it's just one direction as long as you know it's down. But when you've got it up and down, then the math, the positive and the negative signs actually matter. Okay, so my VI is plus 22.5. My acceleration is minus 9.8. I'm asked to find how high does the ball rise. I'm asked to find D. Are there any other things that I know? The initial is 22.5, the average is minus 9.8. Trying to find D. Is there anything else that I already know? Yes, very good, Jake. The final is indeed 0. When I say final, what you really mean is at the top. Good, because you do need to know that. That's important. What's my delta V? Change in velocity is final minus initial. 0 minus 22.5. My delta V is minus 2.5. Why? Because I go from positive 22.5 to 0. So my delta V changes by minus 22.5. And I then go A equals delta V over delta T.
So, how can the ball already be moving if it's not out of his hand?
So when it just leaves my hand, like I launch it at 22.5. Right? That's the launch speed. If that 22.5 is not negative, then you're going to get a negative time, which we all know can't happen. And so I get a time up of about 2.3 seconds. Takes 2.3 seconds for it to come to rest if you launch it at 22.5. But the question is, how high does it rise? Before I can deal with how high, what do I have to figure out?
that be what the can you be the answer to B or no?
That would be the answer to B. Yes, it would. That would be the answer to B. So now I have to go V bar equals VI.
No, we just double it. It has to come back down.
We're only, because we're asking how high does the ball rise, we're only talking about that
Yeah.
portion.
Get the answer to B though. You have to know.
Oh, sorry, long in the air, yes, double it. Yes, we'll get to that, Jake, sorry. I apologize, Steve, I didn't read the question when I said yeah. Yeah. I wasn't thinking that far ahead. Okay, so I've got 22.5 plus 0 all over 2. 11.25 meters per second is my average. And now I go V bar equals D over T. And now I go 11.25 is D over my time. And I get a total displacement up of 25.8 meters. Not too bad. Does the negative 9.8 matter here?
Yes.
Yes, it does. Only because that minus, that 22.5 matters, yeah. Will you always be okay if you always use minus 9.8? Absolutely. Sometimes you'll just go, well, that really didn't mean anything. That didn't matter, but so what? Okay, Jake's question is, how long does it remain in the air? If it takes 2.3 seconds to go up, does it take 2.3 seconds to come down? Is it traveling the same distance?
Yeah.
Is it in the same Earth's gravitational field?
Yeah.
Yep. The total time is going to be 2.3 plus another 2.3, 4.6 seconds. T total.
What do you mean, Jade?
All right, I'm going to stop there. I've done a whole lot of yakking today. I know I've sort of overextended myself probably a little bit in your minds. You've got now a problem pack here. You've got several questions. I encourage you to do them all. The solutions will be online if they're not already. Okay? There are some that are absolutely, positively you must do. You can see that number 4 is omitted. You must do the little ones that are checked there, 6 and 7 and 8 and 9. Kyle and the helicopter are wonderful questions to determine, do you get this? Okay, so questions 6, 7, 8, 9 are absolute positives you must do. Okay? I haven't gotten to the weight ones yet, like 16, 17, 18. I will get to those. Unfortunately, I have to go to a meeting tomorrow, but I will go through those on Friday and give you some more time to work on those on Friday. We will likely do that Finding GLab on Monday. Questions before the end here? Okay? You do as many as you think you need to get ready for a test.
What's that?
If that's everyone, then yes. If it's 5 or 6,
That's one.
ready. You're gonna have work on this. Yeah.
I was gonna ask which one was this.
Okay.
You didn't really tell us what you did wrong. You just kept writing put Y. Put